Hi, so I attended the public lecture about cosmology on February 28th at 6 p.m. in the Kolk Undergraduate Learning Commons. Cosmology is the science of the origin and development of the universe. Our speaker was Professor Tom Abel from Stanford University. Professor Abel is a computational cosmologist who explores cosmetic history using just supercomputer calculations. His long-term goal is to build a galaxy one star at a time using just computer modeling. Professor Abel used computer animations to show how the first stars were formed and died, and how stars built up our first galaxies. The first luminous objects in the universe were massive stars, which shined 1 million times brighter than our sun. They died quickly and provided the cosmos with the chemical elements necessary for life. Galaxies started to assemble just 100 million years after the Big Bang, and they are still growing today. First, Professor Abel talked about stars. Stars are constantly being made in galaxies. In our galaxy alone, 3 stars are made every year. Between stars, there is a ton of warm gas. Gravity pulls this gas and dust together to make stars. Massive stars live fast and die young because they run through their fuel quickly. They weigh about 40 solar masses and live for about 10 million years. The leftover structures from amazing explosions of these stars are called supernova remnant, and they are super hot at about 5 e to the 7 Kelvin. These explosions can cause material to actually be expelled 4,000 kilometers per second, and about 1 in 500 stars explode in supernova. We have galaxies actually orbiting inside our own galaxy. And these galaxies, some only have 200 stars, while others are a lot larger with billions of stars inside of them. The distance to the center of our galaxy is about 27,000 light years away. And to put this into perspective, the nearest star to us is about 1.3 light years away. And there are about 10 billion stars inside the Milky Way, which is our galaxy. The most interesting part of the lecture was when Professor Abel talked about how many galaxies there actually are in the universe. And we looked at a very small region of the sky and counted the galaxies in it. That image was called the Hubble Extreme Deep Field, which was assembled by combining 10 years of NASA Hubble Space Telescope photographs, which were taken of a patch of sky at the center of the original Hubble Ultra Deep Field. By collecting faint light over many hours of observations, it revealed thousands of galaxies, both nearby and very distant to us, which made this image actually the deepest image of the universe ever taken. This image can only see 1 out of the 32 millionths of the sky and includes galaxies 10 billion times fainter than what the human eye can see. We expect to have more than 160 billion galaxies in the visible universe alone. And to take a picture of all of these 160 billion galaxies, it would take over 2 million years with the current Hubble Space Telescope. How crazy is that? And so what goes into the evolution of the universe takes many factors, which can include gravity, dark matter, gas, chemistry, radiation, star formation, feedback. So it's not just a couple concepts going into the evolution of the universe. It's actually a lot more than we think. And at the end of the lecture, Professor Abel brought up a really interesting point, saying that we can actually take cosmology to a personal level. So I decided to research this more in depth, and I actually found that many of the atoms in our body, which consist about 10% of our weight, are actually 13.8 billion years old. And almost nothing in our body is younger than 4.5 million years old. How crazy is that? So let alone I'm 19, but what makes up my body is older than 4.5 billion years. And about the amount of one of our fingers, so this much, used to be in the first generation of stars. The very first generation. And around 1 billion massive stars helped make us. If you think about it, some of our atoms used to be as much as a million light years apart. How crazy is that? So that was my little summary of the public lecture I attended, and I hope you like it.